Today we're going to talk about properties of parabolas. In this first problem it says to identify the vertex and then write the equation in vertex form. In order to identify the vertex, I have to use the equation x equals negative b over 2a. That's the formula that you use when you are finding the vertex if the equation is already in standard form, and in this case it already is. So with this we know that a is going to be 2 because it's the coefficient on the squared term, b is negative 4, and c is negative 2. From there, all I do is plug it into this formula, negative b over 2a, so x equals negative of a negative 4 divided by 2 times a, which is 2. Now a negative times a negative 4 makes a positive 4, and then 2 times 2 is 4, so we know x is 1. Now when we're finding a vertex, we're always finding a point. We only have the x-coordinate here, so we still have to find the y. Well, we know that y equals 2x squared minus 4x minus 2, so that means I can take this 1 and plug it in for x and get y. So y equals 2 times 1 squared minus 4 times 1 minus 2. 1 squared is 1, times 2 is 2, 4 times 1 is 4, and then minus 2 again. So it turns out that y is going to equal negative 4. So our vertex is 1, negative 4. Well, then the problem says to write the equation in vertex form. We have to know what vertex form is. It looks like this. Y equals a times x minus h squared plus k, where h and k are the vertex. Well, so we found the vertex to be 1 and negative 4, so h is 1 and k is negative 4 in this case. So now I just plug it into this format. A we know is 2, so I'm going to plug in a 2 here. I have x minus 1 squared plus negative 4, and of course that's going to simplify to look like this, and that is our equation in vertex form. Next problem, we're going to graph this equation and then identify the domain and the range. So I have my calculator here. I'm just going to punch it in. I have negative x squared minus 6x minus 10. Hit graph. Now my graph is a different format because of what I had punched in last time. So again, zoom 6. We'll take it back to normal. So now I have this graph here, and I'm going to go to the table so that I can get some points. I know at negative 1 we're at negative 5. At 0 we're at negative 10. Negative 2, negative 2. Negative 3 is at negative 1. Negative 4 is at negative 2. So I got a couple points here on my graph so I can get a rough sketch of what this looks like. Now we have to find the domain and the range. Well, the domain for a quadratic is always negative to positive infinity. Also, if you think about it, this always gets pushed out to the left, and this side always gets pushed out to the right. So it's negative to positive infinity. Now the range is from the bottom to the top. The bottom of this graph, you'll notice, is going down, so it's going down to negative infinity, so that's where it starts. And then the top of my graph, since I have a maximum here, here's the top, which is at negative 1 on the y-axis. So our range is from negative infinity to negative 1. We'll do another set of problems. This one here says to identify the max or min, sketch the graph, and then find the domain and the range. So we're going to do one of these back problems here. Negative x squared minus 10x minus 30. So again, I'll punch it in my calculator. Graph it, and then use my table to find the points that I need. So at negative 4 I'm at negative 6. Negative 3 we're at negative 9. Negative 6 is at negative 6. And negative 5 is at negative 5. My graph looks something like this. Now, we were told to find the domain and the range, and then the max or the min. Well, this graph has a maximum because it has a high point. High point is right here, which is at -5, -5. So our maximum is -5, -5. The other way that you can see that is if you're looking at your table, all these numbers before -5, so the more negative numbers I have here, -10, -9, -8, -7, they're getting smaller up into this point right here, -5. You zoom in so you can see that. So these numbers are going to get bigger to -5. Well, then on the other side of that, here's -5. Now they start to get smaller again. So you can see that on either side of this -5, my numbers are smaller. So my maximum is -5, and the x-coordinate of that is -5 as well. So that's how we get -5, -5. Well, again, the quadratic, the domain is negative to positive infinity. And then my range is from the bottom to the top. Since this is going down, the bottom is somewhere at negative infinity, and the top is at -5. We'll do one more problem. Do number 12 here. We have x squared minus 18x plus 86. It says to find the vertex, the axis of symmetry, and the max or min. And I also add the directions to find the zeros as well. So the first thing we need to do is say what A is, which is 1. B is -18. C is 86. Our vertex, remember, is always found by -b over 2a. I'm going to plug those in. X equals negative of a -18 divided by 2 times a, which is 1. So that's going to give me a positive 18 over 2, which means x is 9. Now that I have found x, I have to get y, because remember, vertex is a point. So I'm going to plug x in here. So y equals 9 squared minus 18 times 9 plus 86. Go to our calculators here. We have 9 squared minus 18 times 9 plus 86 gives me 5. So y equals 5. My vertex is 9, 5. Next, to find the axis of symmetry, we just use the vertex. We know that the axis of symmetry always goes through the vertex, and since it is a vertical line, my axis is going to be x equals 9. Well, the maximum or the minimum is always found at the vertex. And if we look at this, this does not have a negative out front. So that means my parabola is going to open up like this, which means I have a minimum. And that's always at my vertex, so my minimum is also at 9, 5. And then the last thing we had to do was find the zeros. So we can graph that real quick. Now if we look at this graph, it doesn't touch the x-axis at all, so it has no zeros. And that's all.